All right, let's look at interior angles of polygons. So when we talk about polygons, we are referring to closed plane figures formed by 3 or more line segments. So closed means that all the sides connect. You don't have any gaps. This is called a polygon, which really just means many sides. Now it says is a circle a polygon? And the answer is no, because a circle is not formed by line segments. It's just a curve. So no, a circle does not count. But in general, we're talking about two-dimensional shapes. Now each polygon is made of sides and vertices, or vertex is the singular. So vertex, or again the plural is vertices. Now these are where each side of the polygon intersects with the next side, and they form angles. The sides, each vertex has an angle. So what we can do is figure out the total sum of the interior degrees of each of the angles of each polygon. And we can do that by splitting each polygon into triangles. And so if you remember, the sum of the angles of a triangle is 180 degrees. So we can use this fact to find the total number of degrees of larger polygons as well. And we do that by splitting each polygon into triangles, making sure that all the vertices of our triangles correspond to vertices of the polygons. So for example, a quadrilateral has 4 sides. We're going to split that into 2 triangles. And they each have a total of 180 degrees on the inside angles. And so we just add those together and we get 360 degrees for our quadrilateral. So any quadrilateral, any 4-sided polygon, has a total sum of the interior angles is 360 degrees. Now, a pentagon has 5 sides. We can split that into 3 triangles, each having 180 degrees. And notice how all the vertices of my triangles, and I'm just kind of roughly sketching them, are on the outside edges of the polygons. They correspond to vertices of these polygons. And that allows me to use this trick. If I split it into triangles where they intersect in the middle, it doesn't work the same way. So now we just do 180 times 3, which would be 540 degrees for a pentagon. I have a feeling I'll need a calculator for the next one, so I'll bring that up. For a decagon, 10 sides. Again, we're going to draw as many triangles as we can. And I find it easiest to think about if I just always originate from the same point when I'm splitting these up. So we have 1, 2, 3, 4, 5, 6, 7, 8 triangles. So we have to do 8 times 180, which is 1,440. Now, something to keep in mind is this pattern we're seeing where the number of triangles, here I had 2 triangles for quadrilaterals, 3 for pentagon, 8 for a decagon, is 2 less than the total number of sides of the shape. And that's because we can connect from one vertex to every vertex in the shape except for 2, the ones directly adjacent to the point we choose. So this can help us come up with a rule for how to find the sum of the interior degrees of any number of sided shape. We can create an equation. And we'll do that here in just a minute. So first, let's fill out this chart, see if we can figure this out. So we know some of these. Triangle, 3 sides, 180 degrees. 4 sides, we'll say a quadrilateral. And we found that up above to be 360 degrees. For a pentagon, we saw above that that's 540 degrees. We haven't done a hexagon yet. But if we follow this pattern where we add 180 each time, I can just do 540 plus 180, 720 degrees. For a heptagon, you might also hear that called a septagon. For 7-sided, add 180 to 720, 900 degrees. For an octagon, that's going to be 1080. For a nonagon, 9-sided, 1080 plus 180. Didn't want to get that wrong. It's 1260. And then for our decagon, from above, we found that to be 1440. And so when we call this for an n-sided shape, let's call that an n-gon. For any number, we can come up with a rule. We kind of talked about it already, because we make a number of triangles that's equal to 2 less than the total number of sides. For 4-sided shape, it was 2 triangles. For 5, it was 3. And for 10, it was 8. So what we can do is say, if n is the number of sides, we can subtract 2 and then multiply by 180 degrees. And that's how you can find the total sum of the interior angles of a shape if you know how many sides it has. You can imagine splitting it into a number of triangles, multiply that number of triangles by 180 degrees. And of course, we can use this idea to solve problems. So for example 3, it says solve for x, and we have a triangle, 50-degree angle, 85-degree angle, and some expression. So if we add all those together, x plus, and then we'll do 50 plus 85 plus 53, which is 1448. That's not right. I had my previous number in there. 50 plus 85 plus 53, 188 is a much more reasonable number. Now that should add up to 180 degrees. That's how many degrees are in a triangle. So now we just solve this equation. Subtract 188, and we get x equals -8. For example B, we have a pentagon, hexagon, 1, 2, 3, 4, 5, 6 sides. That is a hexagon. And from our table over here, we found a hexagon has 720 degrees. So we know this is going to equal 720. And now I can add up these angles. Remember, this square means we have 90 degrees. So my equation is x plus, and now I have to add up all these angles. 90 plus 90 is 180, plus 140, plus 150, plus 130 is 600. So x plus 600 equals 720. If I subtract 600, I get x equals 120 degrees. Well, I could just say 120. The degree symbol's already there, so x is 120, but either way. And finally, we have a quadrilateral here for example C. A little bit more going on, but not too bad. Same idea. This is all going to equal 360 degrees. So I have to add these up. 2x plus 2x plus 2x plus 2x is 8x. 20 plus 20 is 40. And this equals 360. So subtract 40. So 8x equals 320. Divide by 8. And x equals 40. So we do have a table here of our interior angle sums, but really the most important one on this table is here. We just subtract the number of sides by 2 and multiply by 180. And I suppose an important one to remember is the triangle, because that's where all of this comes from anyway, but hopefully you already knew that. So there you have it, an easy way to find the sum of the interior angles of a polygon. Subtract the number of sides by 2, and multiply by 180.